This is the most unliked place on Earth, a desert that is almost empty of human life. But still, a great example of engineering is being made here, which is no less than a miracle in itself. The construction of the world's largest telescope is underway at the top of a mountain 10,000 feet above sea level, in the middle of the Atacama Desert of Chile. When this telescope, 40% higher than the Leaning Tower of Pisa, is completed, it will be able to see the distant planets of our universe 5,200 times more closely than our eyes. And these images will be 15 times sharper than the Hubble Space Telescope. But making the world's largest telescope in the driest part of the Earth is no less than a miracle. After the Atacama Desert and Antarctica, driest area in the world, where some parts are found where there has never been a drop of rain in history, how can this telescope go back in time and see the first galaxies, stars, and planets of the universe? How can this telescope help scientists find other planets like Earth? And most importantly, what difficulties did the scientists and the construction team have to face during the construction of a football field-sized dome at the heights of the Atacama Desert? Welcome to Recap English Videos once again. Viewers, this is the Atacama Desert of Chile, 1,000 kilometers spread on the Pacific Ocean front of South America. After Antarctica, it is considered the driest place in the world. Here are such unique colors of nature that we are seeing for the first time. Here, fireflies are found in abundance. But one thing that is most important for life is not found here: water. The landscape of Atacama Desert is such that it does not rain here. There are even some areas that have not seen a drop of water in history. On the basis of all these features, Atacama Desert presents a scene of an alien planet. And perhaps that is why the European Space Agency also tested its Mars rover here. Chile's capital, Santiago, is 1,300 kilometers away and 130 kilometers from the city. On this mountain, 10,000 feet above sea level, this extraordinary project is under construction, which will give humanity a chance to see the other world in space. The European Southern Observatory, also known as ESO, is building a very large telescope on this spot. Extremely Large Telescope, ELT in short. Although its construction is not complete yet, it will not be difficult to guess why it has been given this name. A very large mirror will be installed in this telescope, whose diameter will not only be 39 meters, but will also be 4 times larger than the largest telescope ever. It will be 4 times larger than this mirror can surprisingly collect 10 crore times more light than a human eye. But the condition is that not a single drop of soil falls on it. To avoid this, the telescope will be covered with a very large steel dome, which weighs about 2,400 pickup trucks, almost 6,000 tons. This dome will have 2 large doors that will remain closed during the day. This dome is so high that the Statue of Liberty can also be placed inside it. And if we talk about expansion, a football field can also be built inside it. A high-tech platform has been installed below it that makes the entire telescope 360 degrees. It makes it able to rotate. Construction, especially where there were no roads, no electricity, and no water. And on top of that, the construction was on the top of a mountain. For this project, ESO first examined many places in Europe, but in the end, they had to choose this location in South America. ESO is a government organization in Europe, which has members from 16 countries. ESO's project head says that there are many reasons behind selecting this place for ELT. First of all, they needed a place for the telescope where there is no city far away. The reason for that is light pollution. You must have seen that even at night, there is often light on top of the cities. And if there are clouds on top, they are also clearly visible. This light is much more than the light of a star, thousands of light years away, which can spoil the image generated by the telescope. But many such locations are also present in Europe on the mountains. So why was this location in South America chosen? It is not enough to save the ELT from light pollution. It is also very important for the sky to be clean. Most of the tropical weather in Europe is caused by clouds. But since Atacama Desert is one of the driest parts of the world, there are no clouds for 320 days out of 365 days of the year, which is very important to see distant galaxies. In 2010, the ESO team tested at various locations and finally found Atacama Desert's location to be the best, a 3,000-meter high mountain known as Cerro Amazonas. But the problem was that, like other mountains, it was a very steep mountain. That is, it would not be possible to do any kind of construction on it in this condition. The mountain peak was cut, and then the area was cleared of 7 football fields. Imagine a 3,000-meter higher mountain and a huge terrain. The work was difficult and dangerous with the help of excavators. The construction team thus helped with the explosives in 2014. Explosives with a remote controller. In this process, a 100-meter section of the mountain was blown, in which 4.7 million cubic meters of soil was found. It was so much soil that 1,911 Olympic-sized swimming pools could be filled. After removing the soil and stones, the upper part was straightened, and a path was also made to reach the top. But this was just the beginning. A straight field, like the 7 football fields on top of the mountain, was formed, but a very big problem arose along with it. An issue that would have forced the construction of the ELT to stop for the next 5 years. The engineering team noticed sinkholes forming all over the top of the mountain. They would fill them again, but after a while, many spots would get stuck inside. This was the biggest issue on the way to the foundation of the ELT. In fact, the explosives that were used to blow up the top of the mountain caused a lot of damage to the mountain's core. There were cracks in the rocks, and the soil started getting stuck in places. After a few months, there would be movement in the rocks, and new sinkholes would be formed. To deal with this problem, the engineers did many drills in this field and artificially stabilized the ground with the help of vibration, so that all the sinkholes are formed at once. Finally, the vibration method worked, and the top of the mountain was planned once again by filling the sinkholes. This whole process took the next 5 years to complete, and now the next stage was to put the foundation of the ELT. This was not going to be an ordinary foundation. Atacama Desert is a seismically active region where earthquakes are very common. To save expensive parts of the telescope from earthquakes, the foundation was kept separate from the dome above. There are many hydraulic shock absorbers installed between the foundation and the dome, which prevent the earthquakes from reaching the metal dome and the telescope mirror inside it. In 2023, the foundation's work was completed, and now it was the turn of the telescope's amazing dome. The steel structure of the dome was made in different parts of the dome in the base camp below the mountain. The remote-controlled trucks were used to transport these parts to the top of the mountain, one by one, reaching the steel frame to the top of the mountain. After reaching the top, the cranes joined these terrifying structures as if they were joined together like Legos. In order to reach this part of the Atacama Desert, the roads were networked, very large telescope, 39 meters. For now, to control this large mirror, a structure is being made inside the dome, and how big it is, you can guess from this worker, which is standing on top of the frame. This 39-meter mirror is being made by combining a total of 800 small pieces. Its job is to multiply any light coming from space and reach the secondary mirror, M2 to M3, and then to M4. M4 will make the image sharper, and for this purpose, powerful laser beams will be used on the dome. These lasers are usually set at a wavelength that excites sodium atoms in the 90-kilometer sky. With this, they start shining and become an artificial star. Telescope uses this artificial star as a reference point so that it can be found in real time how the atmosphere is distorting the light. When the distortion in the atmosphere is found, then the distortion in the image of the telescope is easily eliminated. This whole process is called adaptive optics. After the image is removed from M4, this light goes to M5, and here the image is corrected and sent for processing. There is a lot about the magnificent working of the telescope. The biggest question here is, what will we get through ELT? ELT will be the only telescope that can take direct photographs of exoplanets outside our solar system, those planets that are at risk of being affected by life. For now, these exoplanets can be seen by other telescopes indirectly. Only when they pass in front of their star, their shadow is visible. Through direct photography, we can find out what the atmosphere is like on those planets. And from the atmosphere, we will know whether there is water there or not, carbon dioxide or oxygen. Or is it a creature that is producing pollution like Earth? Because of such a large ELT mirror, a lot of light will be able to accumulate in it. And through this, we can see in the early days of the universe. If you don't know, let me tell you that light has a fixed speed and it can't travel faster than that. Taking advantage of this, we can easily see the past of the universe. A simple example of this is the first ray of our sun. When the sun rises every day, we are actually seeing the past of the sun, because the light of the sun takes about 8 minutes to reach the world, 1,340 billion years back in the universe. That is, its mirror also captures the low light that came out of the universe 1,340 billion years ago and has reached Hubble today. On the other hand, the 39-meter-wide ELT mirror is 10 billion years older than the Hubble telescope. That is 1,350 billion light-years away. According to scientists, the Big Bang, which created our universe, happened 1,380 billion years ago, which means that it can capture the scene 30 crore years after the birth of ELT universe. Here it is also important to know that ELT is a big space, but it will be only the biggest telescope based on mirrors. Telescopes have a very big dish in them, like in the Golden Eye. Instead of a mirror, these telescopes see through radio waves in the past, and then their images are made through a computerized process. But to look directly, the ELT is still going to be the largest telescope in the world. Let's talk about the upcoming expenses on it. Surprisingly, the cost of the ELT has been estimated to be 160 billion. 160 billion, 13 crore 60 lakh rupees. This is almost the same expense as it took to build Burj Khalifa, the tallest building in the world. According to experts, the construction of the ELT will be completed in 2029. After being fully prepared, they may be able to answer the biggest question. Are we really alone in this universe? Or is there life on a planet like Earth, thousands of light years away? Is a life cycle have on another place similar to Earth? I hope you will like and share this video of Recap Englishes as well. Thank you so much